Hello my dear students, how are you all? Welcome to the Karnataka YouTube channel. I hope all of you are doing good. So today is day 54 of our series 60 out of 16 KCET mathematics in 100 days. Today I'm starting bacha new chapter 3D geometry. Okay, session 1 will talk about only basic concepts of direction cosines, direction ratios, okay, and we'll see equation of a line in vector form, in parametric form and Cartesian form with respect to the direction cosines and direction ratios only. Okay, so I hope this is clear. Now we're going to solve questions again on these concepts. I've taken total of 9 to 10 questions that we'll solve in the session only. One more thing, so for this chapter I have done these concepts, right? I've done this concept in the vector algebra also, but we'll see more application of these concepts in the 3D geometry. So let's start with the session number 1 of the 3D geometry, and first coming up is what? The direction cosines. So if you remember, okay, so what is direction cosine, bacha? What is the direction cosine? What does this word means? Direction cosine, sir. It means, first of all, if I consider a vector AB, let's say, okay, we know one property that I can translate the vector AB parallelly in the same plane, it remains unchanged, okay. So if a vector AB is translated parallelly to the point origin O, okay, and I get the same vector, I can rename it as QP, okay. So whatever is the angle of inclination with the axes for the vector QP, it will remain same for vector AB also. How come, sir? Because vector AB and QP are parallel vectors in the same plane, right? So remains unchanged. So angle of inclination for vector QP, if you can see here carefully, with the x-axis it's alpha, with the y-axis it's beta, with the z-axis it's gamma, okay. So if I ask you what's the angle of inclination for the vector AB with the axes, it'll be what? It'll be x. With x, it'll be again having alpha. With x-axis you'll have what? Again alpha. With y you'll have what? Beta. And with z you'll have what? Gamma as the angle of inclination. Great. So if you're talking about what? Direction cosines, no? So we'll apply what to this? We'll apply cos alpha, cos beta and cos gamma to this, है ना? And this is called as your direction cosines given by L, forgive me, M and N. L, M and N. Okay, L, M and N. We also know this result, if you remember, L square plus M square plus N square equals to 1, right? We have learnt about this. So we write this as cos square alpha plus cos square beta plus cos square gamma equals to 1, replacing L, M, N as cos square alpha, cos square beta and cos square gamma equals to 1. Okay, now moving on to direction ratios. So these are those values, means this value is such values. So if I take, let's say the values to be A, B, C, so those values for A, B, C, for which this value L by A, M by B and N by C, this ratio becomes equals. The values of ABC, those values of ABC which will make this ratio equal to certain constant lambda is called as direction ratios. It's called as direction ratios. Please read here. Are the direction ratio cosines, okay, and the ABC be 3 numbers such that this ratio becomes proportional, okay, means it's equals to some constant lambda, then ABC is called as direction ratios, okay. Now one more thing, if you cross multiply this, you're gonna get what? You're gonna get, check here, if I take this lambda to be, it's a constant, right? I can take it to be 1 by lambda also, na bacha? It's a constant, I can take it to be 1 by lambda also, correct? So if you cross multiply, you're gonna get what? Multiply this with this, you're gonna get what? Please check here. You're gonna get lambda times L equals to A. Same way lambda M, same way lambda N. Okay, so this is the way to write with respect to write the direction ratios with respect to direction cosines with a ratio or the constant lambda known. Okay, lambda known. Chaliye, see here. With this lambda known value, you can represent direction ratio and direction cosines in this way. A equals to lambda L, lambda M for B and lambda N for C. Okay, great. Now direction cosines and of a line passing through 2 points. Okay, how will you find direction? So first of all, how can you find direction ratios? How will you find direction ratio, bacha? Just check the difference between the coordinates. Okay, please check. So x2 minus x1, y2 minus y1, z2 minus z1 is what called? It's called as direction ratio. So it's called as direction ratios. I can write it ulta also with the sign change, x1 minus x2, y minus y2 and z1 minus z2. This also is called as the same thing, direction ratios. What about direction cosines? You have to divide this by, bacha, what? PQ. What's PQ, sir? The length of the vector PQ. Please check here. If this is the point P, this is the point Q. PQ will be what, bacha? Tell me. This is the magnitude of the vector, right? if I write in the vector form, how I write the position vector for P? I write OP as what? I write this as x1 I cap, x2 j cap, and x3 k cap, right? Same way I can write OQ also like this. Okay, this was in terms of y1, right? I did not see this, so please forgive me. Okay, 1 second. This is x1 I cap, y1 j cap, and z1 k cap, and for this I'll get what? x2 I cap plus y2 j cap and plus z2 k cap. So what is the position vector of PQ going to be? The difference of this, so x2 minus x1, y2 minus y1, and z2 minus z1. So if I am asking you to find the magnitude of the vector PQ like this, what is it going to be? x2 minus x1 the whole square, y2 minus y1 the whole square, and z2 minus z1 the whole square. We've learned this in vector algebra. That's what it is over here. Please have a look, right? For x component, y, and for z. Okay, so with this known, this is the way to write what? Direction cosines. This is a direction cosines, and these are direction ratios. Okay, this we got the relation from here. Have a look. Okay, chaliye, great. Now projection of the line segment joining 2 points on a line. Okay, what is this going to tell me here? Please tell me here, what is this? The relation is what? Same thing, no? Have a look, same thing over here. So what is this going to be? A, B, C are my direction ratios here. A, B, C are what? My direction ratios here. If I'm looking to find what? L. What's L, sir? Direction cosines. I can write this in terms of this. This is going to be for only what? Only for x component A, B, and C. Okay, B will be for y, and C will be for z. Okay, please check. A upon a square by b square plus c square. Same goes over here. And if you're writing for x-axis, y-axis, and z-axis, means you're taking the component across x-axis, y-axis, and z-axis. Please check here. The direction cosine value will be 1, 0, 0. How come, sir? Because if you take here B and C as 0, please let me show you. L equals to A upon A square plus B square plus C square, sir. Yes, B and C value is 0, right? What are you going to get? You're going to get this A as A upon A square. This will be what? A upon A. Answer is what? 1, sir. Please have a look. Okay, rest will be 0 again because B is 0, right? Over here, C is 0. Okay, same if you do for y-axis, you'll have what? You'll have B as known, other will be A and C will be 0. So you're going to get this 0, only B, the y component will be 1. Rest again for the z-axis, you're going to get what? 0, 0, 1. Please check. A and B will be 0, C will be a non-zero number, so 0, 0, and 1 again. Okay, because again A and B will become 0, so you'll have C by C square root will become C by C, so simply 1. Okay, this is the projection across, direction cosines across x, y, and z axis. Okay, chaliye. Moving on, some important points. Let's see, what is it? L, M, N are direction cosines. We know this condition, no? This is always true, but not this. This is not true all the time. Okay, great. The L square cosines, direction cosines square sum is always 1, but not for direction ratios. Okay, chaliye. Direction cosines of a directed line are unique. Correct, na? Lambda. So based upon the lambda value, check here. What is this L, sir? This L is cos alpha. If this angle alpha is unique, cos alpha will also be unique, right? Same way, if angle beta is unique, cos beta will be unique, right? So direction cosines L, M, and N are what? Unique in nature. Whereas if you see the direction ratios, A equals to what? What is it? It was lambda L or L lambda, right? So based upon this lambda value, okay, this number, A value will be changed. That's why you will not have direction ratios as unique. Okay, now point number 3, direction cosines of a line can always be called direction ratios. Correct, if the lambda is 1, I can call that way. Okay, but you cannot call reverse is not true, means I cannot call all the time direction ratios to be same as direction cosine. I can call direction cosines to be same as direction ratios, whereas I cannot call direction cosines to be same as direction ratios. Okay, so pardon me, I just repeat the same thing. I can say direction cosines same as direction ratios all the time, but this direction ratio cannot be called all the time same as direction cosines. Only case which is true is when this condition is valid. A square plus B square plus C square equals to 1. Then you can check here, this will be matching with this condition. You'll have, then in this condition only we can call what? Direction cosine and direction ratio same both ways. Okay, let's move on. Yes, now Acha, you got it, right? You got this, no? What is it? So the case is only when we can call what direction ratios to be direction cosines if I have this condition true, a square plus b square plus c square equals to 1. Only in this case bacha we can call what direction ratio to be equal to direction cosines. Okay, so this is the point number 3. Moving on to question number 1, let's see. If the direction ratio of a line are 1, minus 3 and 2, what is given here? Direction ratios here, sir, please check. dr means a is given as 1, b is given as minus 3, and one second Balak, minus 3, and c is given as 2. Then find out direction cosines. Remember this, L is equals to what bacha? A upon this, right? Have a look, just learned here, a upon a square plus b square plus c square. Okay, both plus minus signs. Okay, so let's find it out. What is a bacha? 1 here. What is this value going to be, sir? 1 plus 9 plus 4, correct? 1 plus 9 plus 4, how much is that, bacha? This is going to be 1 by root 14, right? Since this is both sign plus minus, we can write it as plus minus for L. For M, what we can write, bacha? Same way, minus is there first, so minus plus 3 by root 14. So here for plus minus, because it was plus 1, right? Here it is minus 3. It means first one will become negative, second will be positive. What about n, sir? Same way, we'll write this as 2. So 2 plus minus upon what? Upon root 14, sir. These are my values of direction cosines when direction ratios are known. When the direction ratios are known as 1, minus 3 and 2. Okay. Simple enough. Moving on to question number 2. Chaliye. Find the direction cosines of the line joining, right? So with the 2 points known, what we can do? We can find direction ratio easily, right? No? Yes, we can find direction ratios, right? How we find bacha direction ratios? Remember this, a is given as simply x2 minus x1. How much is that going to be? Tell me here. 1 minus. So minus 1 minus 0, how much is that? Simply minus 1. Okay. What about b? Sir, y2 minus y1. So what is going to be this? 6 minus 7. How much is that? Simply minus 1. Last one, c. So 6 minus 10. Right? 6 minus 10. How much is that, bacha? Minus 4 again. So I have a as minus 1, b as minus 1, and c as minus 4. How do you write direction cosines now? So L will be equal to what? Minus, so if you find this value, AB length, how much is that going to be? It's going to be minus, okay, minus 1, so 1 square plus 1 square plus how much is it? 4 square, right? How much am I getting? 4 plus square 16 plus 2 18, root 18, right? How much is that going to be, bacha? 9 into 2, so 3 root 2. 3 root 2. So my L value will be what, sir? Please check. Minus 1, okay, upon 3 root 2, and M value will be, bacha, what? They have asked us to find what? Direction cosines, no? So M value will be what? Minus 1 again. Check here. Minus B is this. So B is minus 1 upon same value 3 upon root 2, and N is what? Minus 4. So minus 4 upon what going to be? 3 upon root 2. But I can take both the signs. So here plus, here also plus, and here also plus. So both negative and positive are possible. L is minus 1 minus plus 1 by 3 root 2 minus 1 plus 1 upon 3 root 2 and minus 1 and plus 4 upon 3 root 2. Okay, this is my value of direction cosine. So have a look. Okay, 1 second. Final answer is here. Chaliye. Clear? Simple problem, very simple, sir. As I said, we have learned these concepts, but let's apply some concepts to additional problems. So let's look at this question number 3. Acha, I think I've solved this question in your vector algebra also, right? They're asking us to find what? Sine square alpha, sine square beta, and sine square gamma, sir. Before I do that, remember this property. L square plus m square plus n square equals to 1. Great. So what? Cos square alpha is, cos alpha is L, right? So cos square alpha plus cos square beta, correct? Plus cos square gamma equals to what? 1. simply. Okay, so I'm going to use this now in this condition. What they've given, what they're asking us, value of this sine square gamma. What is alpha beta gamma? The angles with the coordinate axis. Okay, chaliye. Write the identity 1 minus cos square alpha, excuse me, for this, and 1 minus cos square beta for the second one, and the last one will be plus 1 minus cos square gamma, sir. 1 plus 1 plus 1, so 3. Take minus common. Cos square alpha plus cos square beta plus cos square gamma. 3 minus, how much is this, bacha? This is simply 1, sir. So 2. Any option like this? Please check. Option number A is correct, sir. Got it? Option A is coming as 2. This is your answer. Okay. Please have a look. We have used this property for the direction cosines. L square plus m square plus n square equals to 1. Okay. Moving on to the next question. Question number 4, sir. If a line makes angle 90 degree, 135 degree and 45 degree with x, y and z axis, then find its direction cosines. Arey, simple, no? Alpha is given as 90 degree, beta here is given as 135 degrees, and gamma is given as 45 degrees. They're asking us what? They're asking us simply L is how much, M is how much, and N is how much. What's L, bacha? Tell me. L is going to be cos alpha, right? L is going to be cos alpha. So what? Cos of this value 90 degree. Okay, so cos 90 will be what, bacha? Simply, forgive me, 0. Cos 90 is 0, sir, not 1, sir. Okay, sir, my mistake, sir. LM, what is M going to be, sir? Cos beta. So cos of 135, please check. I can write this as cos of 90 plus 45. So this is nothing but minus sine, second quadrant, right? So cos is negative, minus sine 45 degrees, है ना? Cos 90 plus theta is sine theta, but second quadrant, the angle is in second quadrant, cos is negative, that's why minus sine. So minus 1 by root 2. Last one, sir, n value, sir, cos of 45 degrees, 1 by root 2, sir. So what is my L, M, N value? Please tell me. My L value is coming as 0, M value is coming as minus 1 by root 2, and N value is coming as 1 by root 2. Please check. So options are here. C. Option C is given correct. Okay, so 0, minus 1 by root 2 and 1 by root 2. I hope this is clear. Simplest question ever. That's how the questions are in this particular concept. They're not difficult. Basically the questions on this concept are going to be easy, but application will be there in the coming chapter. Okay, so in the chapter that we're going to start from this next session, this chapter only, we'll have applications now. That's why it's important to remember this simple concept. If a line has direction ratios given again, so this is value of A, B and C, then what are direction cosines? Can we not do it? Right, remember this? We just did it right now. Plus minus A upon this value, bacha, A square plus B square plus C square, sir. है ना? Please check. So plus minus, what is going to be A? 2 upon, please check. A square is what? 4 plus 1 plus 4 again. So plus minus 2 upon 3. 4 plus 4 is 8, plus 1 is 9, 9 root is 3. So plus 2 by 3 or minus 2 by 3. Same way I can write this M as minus 1 by 3. 1 second. Doesn't look like M, sir. M is minus 1 by 3. What about N? N is what? Minus 2 by 3. Minus 2 by 3. Great. So plus minus, again both the conditions are there. Please check. If I take plus for all of it, plus minus, here also plus minus, I'm getting plus sign. If I consider, I'm going to get this as positive, this is negative, this is also negative. Option number D, is it right? Yeah, correct. No, if I take positive sign only, the first positive sign, I get 2 by 3 here. Positive if I take, I get minus 1 by 3. If I take positive, I get what? Minus 2 by 3. It's matching. If I take minus sign, it's going to get what? This two positive, that one negative. Any option like that? The last two should be positive and that is negative. I can take that also as combination. Please check. I can combine in this way. No, if I'm taking only positive sign, I'll get what? I'll get this to be 2 by 3 comma over here minus 1 by 3 comma minus 2 by 3. This is the correct option, okay, which is option number D. But I can also take the negative sign, right? Both are the possibilities, remember? So I can write this as first one negative now, minus 2 by 3. What about second one? Minus with minus will become what? Plus, right? So plus 1 by 3, and the last one again plus 2 by 3. So either you take first option or second option. Is there a second option like this? First positive, last two negative. No sir, no sir, and no sir. Okay, it means this option is correct. Both answers are the same thing. Okay, please have a look. Just considering the signs, first case as positive, second case as negative. Okay, great. Now moving on to the next concept, which is equation of a line through a given point and parallel to a given vector. Okay, so we are looking for a vector. Okay, equation of line in the vector form. Okay, in the vector form, for which means a line which is passing through the point A, passing through the point A. So I can write this vector A to be what, bacha? What is vector A? Vector A is the position vector of the point A. Basically write it as OA. Correct now? I can write this as what? Let's say x1 I cap plus y1 j cap plus z1 k cap, right? है ना? Have a look. 1 second. Plus z1 k cap. This is a known value. The coordinate of the point A is known value, and you also have a known vector B. Okay, B is also known vector. So we are looking to draw a line parallel to the vector B. Can you see this line AP? Isn't this line AP parallel to the vector B? Please check. AP is parallel to vector B and passing through the point A. We're looking to find what? We're looking to find what? The vector, the equation of the line AP. Okay. So for that I have this resulting condition. Please check here. I have this point A over here, point P over here, okay, and I also have this point O over here, join like this, and this I've taken a point R. I've taken a point R on this, or basically point P on this vector, on this line like this, on the vector AP, with the position vector of what? With the position vector of R, and this is unknown, bacha. I call this to be x, comma y, comma z. This is unknown, okay. So AP vector can be written as simply AP vector, okay. What about this R vector? It's like this, and this is going to be my vector A. Now you know this, since AP and B are parallel, since you know this AP and B are parallel, we can write this AP as some constant lambda times vector B, or not? Yes. Now applying the triangle law of addition in triangle OAP, what I get vector R, or simply let's write this. First for AP we'll write, no? We're looking for the line AP, right? So we'll write AP, vector AP equals to what, tell me? Vector R minus vector A, right? So bring this A on this side, I get what? AP vector plus vector A equals to vector R, and from here what I'm getting vector R equals to vector A plus, what is the AP vector? Please check from here, lambda times B. How come lambda times B, sir? Because vector AP is parallel to vector B. This is the general form in vector, okay, in the vector notation of a line passing through the point A and parallel to a vector given as vector B. So if you want in this in the Cartesian form, I can write what? Okay, or I can write this as, please check. So if you want in the actual vector form of this angle, I can write this as what? Check here. Xi cap, I've taken this to be xi cap, R to be what? Xi cap plus yj cap plus z k cap equals to what? A cap is what? What is A? Over here, okay. So I can write here x1 I cap plus y1 j cap plus z1 k cap. This is for vector A, and plus lambda times vector B. I can write vector B as ABC also, or simply vector B. These two are nothing different, just I am trying to explain you what is the meaning of vector A over here. Vector A can be written like this, a known value. So over here I have vector A known, vector B also known, and we are looking for what? For the vector R. Vector R. What is vector R? Position vector of the point P on the line AP. which is drawn parallel to the vector B. I hope this is clear. This is the result, very very important. Please have a look. Okay, this is clear बच्चा. Okay, shall I move on? Great. चलिए सर आगे बढ़ते हैं. In Cartesian form, equation of a line passing through a fixed point. Okay, the point is given like this, and in the direction is also mentioned using the help of what? The direction cosines LMN is given by this bachcha, is given by this. X minus x1 upon L equals to y minus y1 upon m equals to z minus z1 upon n. Okay, and this is the Cartesian form. This is the Cartesian form. Okay, okay, great. Again, in the parametric form, what you can do, just equate this with a constant, let's say a. Okay, they've taken this to be what? Vector. Okay, r. Let's say the constant is what? R. Check here. So I can write this x as what? L times of r plus x1. No, please check here. L times of r, so lr plus x1. Over here, m times of r plus y1 and n times of r plus z1. This is the parametric form, and this is called the parameter r. Okay, if the ratio is constant, it can be written as parameter r, and you can take it by cross multiplying and get x values are lr plus x1, y value as mr plus y1, and z value as nr plus z1. Okay, chaliye, let us move on and solve some more questions. Shall we do it? If the Cartesian equation of a line given like this, Cartesian form is given 3 minus x upon 5, y plus 4 upon 7, and 2z minus 6 upon 4. Then write the vector equation for the line. Okay, let us see. Before that, we can represent, no, we can check here. This x has to come in front, right? If you remember the standard form. So just take minus sign common. First write this, y plus 4 upon 7, 2z minus 6 upon 4. Now take my sign common over here. What I get, bacha? I get x minus 3 by minus 5. Correct, na? I can take my sign common and bring it to the denominator. Over here, y minus 4 upon 7. Over here, what I can do, sir? 2z minus 3 upon 4. What I'm getting, sir? Please check. X minus 3 upon minus 5. Here what? Y minus of minus 4 upon what, bacha? Check here. This is going to be 7 as it is. What is it going to be, bacha? 2 and this cancel. So z minus 3 upon 2. Z minus 3 upon 2. Okay. Now if you take this condition, have a look. X minus 5, x minus 3 upon 5, y minus 4 upon 7, and z minus 3 upon 2 as a constant lambda L. I can write this, please check. I can write this x as what? X as minus 5 lambda plus 3. Okay, y as what, bacha? I can write y as 7 lambda what? Minus 4. Okay, same way I can write z as what? Tell me here. I can write z as please check, 2 lambda plus 3. 2 lambda plus 3. If you combine this together in the vector form, what you get? Please check here with the I cap, j cap, k cap. If I'm writing, I get xi cap plus yj cap plus zk cap, excuse me, zk cap equals to what? I'll write this together. So 3i cap from here, because for x, not plus, minus, right? Please check, minus 4. So minus 4 j cap. Okay, and for this I'll have what? For z component plus 3k cap. Okay, and what I'm getting, plus lambda times what? Minus 5 again I cap plus 7 j cap and plus 2 k cap, sir, plus 2 k cap, sir. So if you see carefully, this is the answer in or equation of the line in the vector form, where this represents what? This represents vector r. This represents what? Vector, let's say I call it to be vector a, and this to be vector b. This is my vector b. Okay, so this is the vector 3i cap minus 4j cap plus 3k cap, where the line is passing through, and this is the line which is parallel to 5 minus 5i cap plus 7j cap plus 2k cap. This is in the standard form of vectors notation. Please have a look. So equation of the line in the vectors form is given like this. This is my answer, picture. Have a look. This is my final answer. Simple enough. Okay, shall I move on to the question number 7? This is clear, right? What did I do? Taken this in the standard form, x should come first. Number is like this: x minus x1, y minus y1. Remember the Cartesian form: x minus x1, y minus y1, and z minus z1, right? Upon lmn. If you take this equal to a constant lambda, I can rewrite this in this form, adding them together in the vector form xi cap, y cap, yj cap, and zk cap. I get this notation. Lambda is taken common from the first set of terms. I get what? Minus 5 plus 7 plus 2, okay, giving me a plus lambda vector b. A is going to be what? 3i cap minus 4j cap plus 3k cap, and b is going to be minus 5i cap plus 7j cap plus 2k cap. Okay, moving to question number 7. Okay, question number 7. A line is drawn in the direction of this, means this is the parallel one, and it is passing through the position vector this. Okay, find the equation of the line in the vector as well as in the Cartesian form. Let's write in the vector form first. So let's call this to be, one second, let's call this to be passing through, right? So this is going to be vector A, and this is going to be what? Vector B. So how we write the resulting vector R? R is given by vector A plus lambda times vector B. Okay, now how will I write it? Let me see, please have a look. I'll get this as R vector equals to, what is A going to be? So 2 I cap minus j cap plus 4k cap, okay, plus lambda times what bacha? This one, I cap plus j cap minus 2k cap minus 2k cap. This is in the vector form, please check. Okay, this is in the vector form. Okay, now looking for Cartesian form. One second. Cartesian form, let's check. So this will look like, have a look, x minus 2 upon what? 1 equals to y minus of minus 1 upon 1 and z minus 4 upon what bacha? Minus 2. Okay, simplify this: x minus 2 upon 1, y plus 1 upon, excuse me, y plus 1 upon 1 and z minus 4, or I can write it as 4 minus z upon 2. Both of them will be right. This is your final answer for writing this equation of the line in Cartesian form. Cartesian form is here, vector form is here. Please have a look. Okay, simple. They have given the position vector of the line, which is giving you the line sense of parallel. Okay, they have given the direction sense, right? So for the parallel vector, we are given the vector form. Okay, and again they have given what? Position vector of the point where they are passing through. Okay, so from there we can get this combination for vector form and Cartesian form. Let's move on to the next question. Question number 8. Find the Cartesian equation of a line through this point 1 minus 2 comma 3 and parallel to the line given like this. Okay, so how will I write the position vector for the given point? How can I write the position vector for the given point? So write it as vector A equals to, please check, vector A equals to I cap minus 2j cap and plus 3k cap plus 3k cap. Great. And what about this? How will I write this? Please check here: x minus 2 upon 3 equals to y minus 5 upon minus 6, and what is this going to be? Z minus 1 upon what bacha? 0. 0 represents what? This represents the c value. Okay, great. So if I have to write the vector for this, okay, what vector? The vector parallel to this Cartesian equation that we are looking for. The line that we are looking for is parallel to this vector, right? It's parallel to this line. So how will I write the coordinate of that? So 3i cap from here minus 6j cap and plus 0 k cap. This is what? This is the vector b, right? This is the vector b. Okay, now if you have to write this, how will I write the resultant vector r? In the vector form, you write this as, please check, I minus 2j plus 3k plus lambda times of what? 3i minus 6j. Correct, na? Okay, so if you check here in the Cartesian form, they're looking, no? They're looking in the Cartesian form. How do they write it? Please check. So x minus 1 from here upon 3 What about this? Y minus of minus 2 upon what? Minus 6. And what is this? Please check. Z minus 3 upon 0, right? So I can write this simply as the last one as Z equal to 3 rho. Correct? Z equal to 3. So what I'm getting, please check. I'm getting this option to be x minus 1 by 3 equals to y plus 2 upon minus 6 and z equals to 3. Okay, z equals to 3. Which option is this? Option number C. Option number C is the correct option. Please check. Okay, sir. Option C is correct, no? X minus 1 upon 3, y plus 2 upon minus 6 and z equal to 3. Z equal to 3. Great. So moving on to the last question of the day, bacha. Okay, I know the session was short. We wanted to complete this basics first and then move on to the next concept in this particular chapter. So let's do the last question of the day. Coming up for you is question number 9. Find the vector equation of a line which is parallel to the vector given like this and passing through the point given like this. So for the given point which is known, I can write the position vector, let's say for this to be vector A. Okay, I can write this point to be what? 5i cap minus 2 j cap plus 4k cap, right? And how I write the resulting vector are the equation of the line parallel to this vector and passing through this point. How I write this? R equals to vector A plus lambda vector B. This is my vector B, right? That's my vector B. Okay, so right here vector A will be 5i cap minus 2j cap plus 4k cap, okay, plus what? Lambda times of what is B going to be, bacha? This one 3i cap plus 4j cap plus 9k cap. What have they asked? In the Cartesian form or parallel form or in the vector form? So vector form. So is this the option matching with any of them? Please check. 5 minus 2j plus 4k lambda times of 3i plus 4j plus 9k. Option number A is correct. Option A is the correct choice. Please have a look. Right? From the given point we got the position vector. Vector A equals to this, and we got this notation for the vector form of the line passing through the point given like this and parallel to the line given with the equation, vector equation of this A cap plus lambda B cap. Okay, A is this, vector A is this, and lambda B vector is over here. Okay, this completes this particular question. With this, I would like to complete the session. The session number 1 on what? Direction cosine, direction ratio is over, and application of seeing the line equation in the vector form, Cartesian form, and parametric form with the help of what? Direction cosines is also complete. I have solved 9 questions on them. So this completes this particular topic. Next we'll see the coming up topics in the 3D geometry. Okay, with this bacha, keep smiling, keep working hard. I'll see you in the next session. Please take care. Bye bye.